Hi, everybody. This is Ms. McClellan here to go over practice checkpoint 7.2 with you. Okay, question 1. A burger joint has two types of burgers, with cheese and without. On a certain day, the burger joint made 53 cheeseburgers and 64 hamburgers. Of the 53 cheeseburgers, 21 were made with a veggie patty and 64 of the 64 hamburgers, 37 were made with beef patty. Make a two-way table to display the sample space. Okay, so we've got to construct a two-way table. I see that I have these variables, cheeseburgers and hamburgers. Cheeseburgers and hamburgers. And 21 of the cheeseburgers are made with a veggie patty. Of the 64 hamburgers, 37 were made with a beef patty. Make a two-way table. So we can do our totals. I've done the number 37. I've placed the number 21. I still need to place 53 and 64. So in total, we made 53 cheeseburgers and 64 hamburgers. We can find out how many veggie hamburgers we made by doing 64 minus 37, which gives 21. And we can find out how many beef we did by doing 53 minus 21, which gives 32. And that makes the total number of burgers we made 132. Is that right? 53, 64, no, not right, 117, not 132. Okay, so this is my two-way table. The next part says, how big is the sample space? Well, the sample space is the size of how many elements there are in it. So it's 117, and that's this problem. All done. Okay, question 2. A school conducted a survey to determine the students' favorite subjects. The results were presented in the following two-way table. So we have freshmen and sophomores, and their favorite subjects could be math or science. We want to calculate the probability that a student prefers math. Okay, so in total, there are 20 students who prefer math in the survey. And in total, there were 40 students who took the survey. So it would be 20 over 40, which is equal to 0.5. The probability that a student prefers math is 0.5. Okay, calculate the probability that a student is a freshman and they prefer math. So that one is going to be 10 over 40, because there are 10 students who are both freshmen and prefer math out of the 40 students who took the survey. And that equals 0.25. Moving right along. Question 3. In question 3, we are asked to refer to the same table as question 2. So this table right here. And we want to calculate the probability that a student is a freshman, given that they prefer math. Now, for conditional probability, we have as our formula the probability of A given B equals the probability of A intersection B divided by the probability of B. Here, A will be freshman. So let's see. The probability that a student is freshman and they prefer math is 0.25. So this is going to be 0.25 divided by the probability that a student prefers math, which is 20 out of 40, or just 0.5. And 0.25 divided by 0.5, if you throw in your calculator, or if you just happen to know, is 0.5. So the probability that a student is a freshman and they prefer math is a freshman given that they prefer math is 0.5. Okay, part B. Are the events prefers math and freshman independent? Well, our definition of independence is that two events are independent if the probability of A is equal to the probability of A given B. Here we have the probability of A for, let me define these variables. A is going to equal freshman, and B is going to equal prefers math. So the probability of A that a student is a freshman, I have not calculated yet. It's 20 over 40, which is 0.5. And the probability that a student is a freshman, given that they prefer math, is also 0.5. So these events are independent. I know because the probability that a student is a freshman, given that they prefer math, is the same as the probability that they are a freshman. Knowing that a student prefers math does not give me any information about whether or not they are a freshman, because these two probabilities are the same. Therefore, they're independent. Okay, question 4. Question 4 says that a game involves rolling 2 dice. The sample space is drawn on the back page. I have it right here. Okay. So a player wins if they roll a sum of 8 or a multiple of 3. So let's just see how many ways can we roll a sum of 8. So first I'll do sum of 8. And I'll do that in yellow. Okay. So let's see. 4 plus 4 is 8. 3 plus 5 is 8. 6 plus 2 is 8. 5 plus 3 is 8. And 6. Ooh, I broke my highlighter. It was on a flat stick anyway. And 6 plus 2 is 8. So these are all of the ways that I could roll an 8 out of the total. I know there are 36 elements in the sample space. So there are the probability of rolling an 8 equals 1, 2, 3, 4, 5 out of 36. I also have to check on multiples of 3. So let's look at multiples of 3. And I'll do that in orange. Okay, so my multiples of 3 are 3, 6, 9, 12, etc. So 3 is a multiple of 3. I could roll a 3. A 6 is a multiple of 3. I could roll 6. I could roll 9. I could roll 12. Just one moment, students. I'm going to press pause and check the. Okay, I'm back. Where were we? Well, wherever we were, I need to count how many multiples of 3 we have. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 multiples of 3. So the probability of rolling a multiple of 3 is 1236. Okay, so then we have to figure out the probability of roll an 8 or a multiple of 3. And that's going to be 5/36 plus 12/36 minus their intersection. But if you notice, these two sets have no common elements. In other words, I have no outcomes which are highlighted both orange and yellow simultaneously. So their intersection is 0. So this just becomes 5/36 plus 12/36, which is 17/36. And I have to check that equals in the calculator. That's about 0.47 with the 2 repeating. All right. Last question. Are the events rolling a sum of 8 and rolling a multiple of 3 mutually exclusive? And the answer is that they are. And I know that because their intersection is 0. So the probability of rolling an 8 and a multiple of 3 equals 0. They have no common elements. Now, if that had not been the case, if they did have results in common, they would not be mutually exclusive, because mutually exclusive encompasses just events that do not overlap. So there's no overlap, so they are mutually exclusive. And that was the last question, everybody. We're done. I hope you have a great day. Please practice, and I'll see you next time. Bye.